this is where we start this morning. So if you have a beam, we consider a simply supported beam. Okay, so uh, when the load is not yet there, when the load is not yet there. Okay, so when we put the load, let's say at the middle, so what happened to the beam is it will bend like that. No, so there should be deflection. No, any material there should be deflection. But in actual, that deflection is just very small. No, but for the purpose of analysis, we make it somewhat obvious. No, so that we can analyze later if we have a bigger figure. No, so but actual is it depends on the flexibility of or the stiffness of the beam. No, if the material of the beam is very small in cross section, even though it's made up of steel, still if you apply a load, it's just very flexible. No, you can just deflect like that. But if you make it if you make the section bigger, so the product of elasticity and I will become larger also. So that's why you have a very small deflection because EI usually is found in the denominator, of the equation for deflection. So the EI is at the denominator. So the bigger the EI, the smaller the deflection. Okay, that's what happens. Okay, so like for example, if you double the load, the deflection also will double. Like for example, I will multiply this 5 times, and the amount delta corresponds to P. So I will say this is 5. So the deflection also will become 5. No, so that is what happened. No, okay, everything will be multiplied by 5, even the bending moment, shear, so it's like that. So we can see that the deflection is corresponding to P, no? So if you increase the P, the deflection also will increase. If you reduce the P, the deflection will reduce. If you make P equals to 0, the deflection will be 0 with respect to that load. Okay, so that is the impact of the P when it comes to deflection. Now, because the amount of load is variable, so the depiction also will be variable. Now, we'll just see if P is multiplied in times, the depiction also will follow that it will be multiplied in times. So that is what happened in actual, no? Because we are dealing with a beam that is elastic, no? Elastic. Okay. So, but as I have mentioned, in actual, we will not allow a bigger deflection because in design, there is what we call limiting deflection because too much deflection is ugly to look or maybe will create bad what we call that illusion that the beam is too weak because it deflects largely, so something like that. So, but too much also of a strong, there is also a good and bad effect. Like good is that your structure will become very strong or very durable, but the other one is very expensive. So other owner will say, I will not build like that. I will just use smaller section or maybe yeah, like that, so that it will be a lot cheaper. But how cheap? So that's why that in design code there is what they call limiting deflection. So there is a limiting deflection. So you cannot reduce the section as much as you want because you are if you follow the code, there are some guidelines when it comes to deflection. Okay. So anyway, that is design. The subject is not design. This is just theory of structure. So this is just science, no? Science. So delta is the deflection corresponding to P. Now, why I use in here as multiplier? Because we know that if we increase the load, the deflection will also increase. If we decrease the load, the deflection also will decrease. So multiplying it by n times, like in P will also produce an in delta. Okay? Why I use big delta? Because it's just a matter of choice, no? I use this symbol delta because delta is commonly used symbol as deflection, no, in most books, no, most books. Okay. So we do not compute deflection here. I only say that if there is a load, the beam will deflect. Okay, and we put name in that. The deflection is denoted as delta. No, in fact, this is a uppercase delta. Okay, a Greek letter. No, uppercase letter. Okay. Now another case is we will expand. We will extend it larger. No? So we will use notation. Di ko mainta. Notation. Okay, so notation. Okay, why we make notation? Okay, so that for convenience purposes, no? So we make notation. Yeah. What is this notation all about? Kanalagong ang ngalan nimo, proper lang nga pag-annotate para when so that when you use it, you can use it seamlessly with other formula nga gagamit og subscript, no? Because some formula uses subscript, especially matrices, no? Doon naman siya mga subscript, no? Like A1, A12, A23, something like that, no? So, example, no? Example. If you will encounter this, A1, 1, 2, A12, no? A12. So that's a subscript, no? A12. Okay. So that's a notation, no? That's a notation. So it does not only E, but this one is something like an element of a matrix. So it says that maybe the first number, the first subscript there represents the row, and the second subscript represents the column. So that's how matrix is being used. The variable in matrix is being used. So it's just like that. No, that's the notation I am talking about. It's no big deal really. No. So here, if we use delta, no, little d, d, if we use small letter d, and we will use I and J. Okay, so we will use small letter d. No? Okay, small letter d. Okay, why you use small letter d? I will explain later. No? This one is a subscript. This is a subscript. Okay, this is a subscript. Okay, it will not be separated by comma anymore, but it means two numbers. So here, I is the first subscript. Okay, the first subscript. And J and J. So, kung gamit ani nga mga notation, medyo makasulod na ta sa equation because the equation usually use subscript, no? So, paste it. So, this one is J, the second subscript, second subscript. Okay? That is the second subscript. Now, ang pangutana, unsa man yung first subscript? Okay, the first subscript is inon lang nato nga the point where load is applied. Okay. Ayun na kaya na, no? Itaon lang nimo ang point asa gi butang ang load mo na imong first subscript. Okay? So, because I have no example here, you cannot see its application, no? But later, no? Later, kung ano tayo application, kita na nila na, no? How about the second subscript? Ano yung second subscript, ha? Okay, the second subscript is where those? So the second subscript J refers to the second subscript. Di niya natin. Okay. First subscript is the yung sa sabutan na niya, it is the point where the load is applied. Okay. What about the second subscript? So it is still the point, no? It is still the point where deflection is observed. Okay? Where deflection is observed. Okay. So, ang second subscript ay sa mga kuan, we will use the symbol. No? Okay. Okay. We use small letter delta as symbol for deflection due to unit load. Okay. D nga gamay mo na siyang gigamit nga symbol sa deflection nga unit load. Kining dako mo na siyang symbol sa deflection sa real load, no. So kung unit load gani, pwede ka mo gamit ani nga symbol deflection, but symbols are symbols, no. Symbols are symbols. They are not really kuan. They could be arbitrary sometimes, but we are just following some sign conventions and notation in other books. So most books use small delta as the deflection for unit load and big delta as the deflection for real loading, no? The applied loading. Applied loading is different than unit load because unit load is just unit 1 with 0. We use unit load in finding deflection also, no? And especially when we touch about Castellanos secant theorem. Okay? Okay. But my point here is just notation. It's just how you are going to name the deflection. So we use two subscript, no? First subscript and the second subscript. Okay. So just like when we use subscript when we are representing an element in a matrix. So you know where that particular element of a matrix is located, at what row and what column, or what column and what row. So it is, their address is based on the subscript, no? Where I'm going to put this. But in deflection, we use delta for deflection due to unit load, and what is added is just the two subscript. The two subscript I and J represents the first subscript, and that first subscript will identify where the load is being applied, no? Where the unit load is being applied. The second subscript there is where the point where the deflection is to be determined, or where the deflection is observed. So, kana lang, no? Kinilang duha, no? Ang isa is load is applied. Okay, load is applied. Ang isa, deflection is observed. Okay, muna mag-apply sila. So, if I have this one, no, as an example for the notation only, no? Kapag na-solve ang problem, ha? Dapat sa number 1, no? Number 1 to bata. Lagi na dapat sa number 1. Dapat sa methodology, no? So, makumpleto na ito ni siya para makasabtan o sabtan na ito ang mga mga pamaagi, no? So, let us say, we will use the same beam, no? Okay, we will use the same beam. Okay, siya. Copy, paste. So we have here a beam that we can use. Okay. Now, if we apply a unit load, I'll borrow the arrow here. Okay, copy, paste. Then move it here. Of course, when you put a load, let us say this one, uh, the beam will also deflect. No, there will be deflection like this. Okay. Okay, that is the deflection. Now we will just change the line into this and that. Okay. So, dili karon ang diferensya, no? Like for example, if this is 1, that is 1. So, remember that is unit load, no? In unit load, sometimes we use unit, but most unit load do not have unit, no? It's just unit. And the direction will depend on how are you going to use it. If you use it upward, then there will be an upward deflection. If you use it downward, you will have a downward deflection. So that is the case, no? It's not always downward, the unit load, but what is important here is the notation. So, ang may tabuda na niya karon is, kung tawag ko na to ni siya nga, okay, ibog. Okay, muna siyang, wala to, beam. Okay. Kung tawag mo na to ni siya nga A, nga kini siya din ni 0.1, ay, 0.1, ang kini siya din ni 0.2, ang kini siya din ni B. So, we will say that if we want to determine this deflection here, okay, this deflection here, okay, that is the deflection there. I will rather call this delta applied at 1 per subscript is where the load is being applied is at 1, where the deflection is being observed is at 1 also. So this is what we call delta 1 1. Okay. This one is delta 1 2. Okay. I will change this with a small letter. Okay. So because it's unit load, I use this letter. Ganito na po ni gamay nga liter. But wag mag-vote sa imo, no? Yeah, kining 1-1. Muna na yung bago karon, no? Bago na siya. Kaya ano, sa una, huwag man talagamit yung subscript. Okay? So, both pasabot ano yung subscript is that, that is the first subscript, no? The point where the load is applied. You will see that the unit load is applied at 0.1. Okay? So that's why it's 1. And the second subscript is the point where the deflection is being observed. You are observing at 0.1, so that is delta 1 1. Now, asab din nato magamit ni 1 2. Di nito makita, no? Di nito makita. Okay. Tumubot ang tagline din muna siya ang 0.2. So, ang tawag ani niya karon is gamit ng yapong kadani, no? The unit load man. Unit load lang i-apply. So, gamit ka nga symbol. It's proper to use this one, no? And this one are what we call subscript. Subscript niya siya. Duha na siya ka subscript. Okay. Nganong 1 man ang primero? Kaya ang 1 is the point where the load is applied. Wala ba ya sa 2 i-apply ang load na ba sa 1? Yang anong 2 man ang ikaduha nga subscript? Kaya observe dali aman sa 2. So, muna bot to sabot. Yan. So, kung mabutang pag yung kaglain, din butang nga din ito si nakaliya. And you call that 3. So, it will happen that this one will become siyang delta 1, 3. Okay? This means that the load is applied at 1, the deflection is applied at 3. Okay. That's it. So, yan na lang pasabot na ako sa notation. No? Notation. Okay. So, ano nagamit tawag gamay nga delta? Because we are using unit load. Now, anong nakay subscript, duha, o sa may buot pasabot ana. So, we call the two subscripts as I and J, the first and the second. The first refers to the point where the unit load is applied. The second subscript represents where the deflection is to be determined. Okay. So, do you have any question, class, about the notation? So from now, we use this kind of notation, no? Because this one will help really. This one will help. So with this, and with the knowledge you have already from our previous lesson, we are now ready for solving sa tawag ani indeterminate beam. So we are already finished with number one, so we are now in number two. So number two is about example. Okay. So it is example ato na butangan. Determine, analyze. No? Say analyze. Analyze the loaded beam. Okay, loaded beam. Okay. So EI is constant. Okay. Okay, so mga beam, no? So, buto na ito beam. Ayun, magulang tag beam din eh. Humari din eh, dadaan, no? Home, copy. Okay, ito na siya ang kopyahon. Okay, so, magutag copy, paste. Mas easier man good man mag-copy paste pa. Pwede siya focus. Okay. Ano naman siya? Patuloy siya. Patuloy siya. Sige lang, ano na. So, mauna ni siya kaon ng beam na ito. Makapin siya patasan. Okay. Now, let us say nga doon na pagid siya support sa tunga. Kay kana siya sayon naman na simple beam no kasi kinsa makasolve ana no so ang uban din na manulod kin no kabalo na mo sila daan. Ngayon siya nga si sir lecture man og nanadaay answer. Kabalo na tadaan na gabalik-balik gikat na sa static kabalo na taan na. So let us say nga doon na siya sa tunga no. Let us say nga kini siya dinhi 4 meters ni 4 meters ni siya 4 meters. Ya, dili na mo deflect kung walay kuan, walay load. So what happened is we will put a load. Okay? We will put a load. Okay, and ang quill niya is natin ng quill. Karaging maging load ba? Sa to pattern siguro. Okay, that's it. Now, downward load na siya. So, ang load ano niya, W gamay. W is equal to Mayo 20 kN per meter. Okay. So if you have this kind of beam, ang imong beam dili na karon kuan kay ngano. Ako analyze ha. Ato sa ni siyang isa, no? Ang kinisya ato ni isa. Kung siya group. Okay. So, mga siya, no? So, tingani mo kung may tabuan na niya. No? Mulam ta din o arrow. Copy, paste. So, ato ng dalong dito. Ano to? Okay. Actually, ang gusto sa kuan, kulahon to gina siya. Kulahon ta na siya kay para makita niyo, no. Actually, ang kuan ani niya, mo ni siyang gitawag og reactions, no. So kapiyon ta na siya, doon na siya ay reaction. Okay, na reaction diha. Reaction diha. Now, ito si nga ruler ang uban no ka gamay gyud kayo og kuan. Dili gid lisod kayo 1 degree internet ta. So, mo na siya ang reaction niya. Okay. So, upat tanan ka reaction. Actually, upat ka reaction. But, we can only use three equations of equilibrium. That means nga, this is indeterminate of first degree. So, number of unknowns, you have 4. Okay. Equation available. Okay. Natay summation of forces X. Natay summation of forces Y. Initial force is x equals to 0. Kopya ko na. Dali. Okay. Okay, summation of force is y. Ito ba kung diyan na daan mo? Ito ang talagang makilang. Okay, kopya ko na ako na siya. Pero kini siya, moment na siya. Moment, kini siya. Hindi siya sinibol. Kini siya, y na siya. Okay, so this one is sakto sa script na siya. Okay. So tulo imong mabuhat, no? So meaning, the solution is you need locking, no? Locking equation because equation available 3 lang is yan, no? 3. Okay, so other equation is compatibility. Other equation is from compatibility. So that is equal to 1. So that will be our solution. Our solution is use of equilibrium plus compatibility. So, na, no? So, muna itong worded na solution. So, what is actually happening here? No? What happened here? Kumuduta sa atong, kung assume na to na siya nga tawag aning elastic, so ang atong deflection na namag na ni. Okay, it's like that. Mura mag-W. I choose a color. So that is the deflection, no? So, and we cannot determine the shear, no? Because when we analyze, it's basically the V and M diagram you are looking, no? This is the most important course in the analysis because once you have the shear and the moment, you could start designing. You can start choosing the section that will make the structure safe because you have some basis. But if you don't have shear and moment as your basis, you don't know what section you are going to use. So you just use the section, maybe, but you don't have any basis, no? So that you have any basis, you have to analyze. That's why analysis of structure is important. But this is you cannot determine the reaction right away, no? So because this is what we call tawag ni ani indeterminate to the first degree, no? So indeterminate to degree of indeterminacy ato lang degree of indeterminacy of indeterminacy is equal to 1. Okay, 1 naman ang ikan sa compatibility, 1 ay indeterminate. So meaning, the method that we are going to use here, method use is approach, no? Approach method, we use the term method of solution. Ang tawag ani niya, let's start with consistent deformation. Method of consistent deformation, tawag ani niya. Method of consistent deformation. Or, this is also called force method. Why it's force method? Because ang force may imong makita una. Or force method. So, ano siya, ang tawag ani nga method niya, akong i-introduce karon, no? This is a classic method, and although kung software onta, kadyot onta kayo, but the reason is that you still have to take your board exam, no? And in the board exams, we know computers, softwares are not allowed. Okay, so we have to solve, to analyze indeterminate structure in classic way. No, so this is it. No, method of solution. So I will just make this. Masaya button na i-italics ko siguro na siya, no? I-italics na ko para kuan. Different siya, no? Different. Okay. So that's it, no? What to nag-analyze, no? But the problem is really there. How to determine the shear moment here? If kabalo lang itong reaction ani, masog na akong shear moment, no? So what is the reaction? No? I know nga ang sa tunga mas dako kaysa daplin. Kaya I know sad nga ang duha ka daplin equal. But ang sum ani nga vertical nga load tanan is 20 times 8, no? So the sum of all the vertical load is 20 times 8. Mura ako may bawaan, no? And then the if you compare the kisinabugatan ang tunga ba nga nag-alsa o kinibas daplin, no? So pwede mo na yung testingan, no? Mag-alsa mo ka ng tabla bitaw. Nga, tanan lang gid mangusog, isa sa tunga duha din sa daplin kung kisay nabugatan, no? Nabugatan. Usually ang sa tunga mabugatan, no? Usually sa tunga gid mabugatan. Okay? That means nga kung kuan palugar na siya, yeah, so maging manana no nga ang nasa tunga mo gyud maladak kuanan bugatan siya og karga, no? So yan na. So ang atong problema dani is kung ano na gid ang reaction, but as of now we do not know. That is why we will, and our equation is not enough. So that's why we use compatibility. Okay. So this is what we are going to use. One naman gid ang compatibility. So kay isa ra siya kay equation. So ang akong approach ani is to make this structure simple. So mitabo na i-remove nimo, no? I-remove nimo ang tunga para mahimo siyang simple beam, no? Mahimo siyang simple. So kung i-remove nimo ning tunga, unsa kay mitabo sa structure, nga ana ba lang gyapon iyang ang iyang deflection ng mga W, no? Mga manigayban, ang iban ko uban sa lain sa tanawan ni sa uban, no? Ako W, unya mo sa siya o iban. Pwede sa siya nga balod. Balod siya, no? Balod sa tubig. Pero, our eyes can see in uniform. No? So, ano na. So, if I am going to remove the reaction, isa lang, no? Either the plate or tunga. So, ang pinakamayo ang tunga, no? It's convenient to do that. So, what will happen if I am going to remove the center support? Sa kay may tabo. Okay? Atong tanahon. Sa may tabo. Magbuhat ako, no? Tingnan mo gining method sa consistent deformation. You are going to remove a redundant support. The number of redundant support is the number of determinacy. So it is first degree ra imong indeterminacy. So isa sa din yung support. So pwede lang isa lang, no? Ayaw na duha. Isa ra gyud. Kung sa number sa degree of indeterminacy mo sa imong paano support. So pag remove nimo ana nya, duta na gyapon ni siya. Nagyapon na siya. Nya mao gihapon, no? Sige siya. Mao gihapon 20 lang gihapon ni siya. W is equals to 20 kN per meter. So, ini siya naalang yapon ni siya. Naalang yapon ni siya. Pero wala na sa tunga, no? Kaya remove ba nimo, no? So, ang consistent deformation nga method, the way it will solve indeterminate structure is to remove the redundant support so that it will become simple beam. Now, this is simple beam. Okay, this is simple beam. Okay. So, ang may tabudan na niya, na siya ay deflection nga ingon ani, no? Deflection. So, ang deflection niya is ingon ani. Hapit na 130. Anyway, so mo na yan deflection. Okay. Mo na yan deflection. And we call this one here, we call this one, di na mo gamit ito itong dilutan nga gamay, no? Dako. Kaya di man unit load ang i-apply. So, yan load ni siya. So, if that is the case, di na mo gamit ito kuan. We will just call this, I will call this point 1. I will call this point, I will call this as point 1. Kaya atas ka. So, I will call this as point 2. Atas ka. I will call this point, I will call this point 3. Mga gyapon din eh. Nagyapon na gyapon eh. Mga gyapon din point 1. Okay. Point 1 is 1. Jadi ni mga gyapon siya point 2. 2. Hindi siya mga gyapon yung point 3. So, kung ano ito sa inanlanay karon, kini siya, gitawag ni siya, big deal ta. Sa isa lang ka subscribe atong gamiton. Kaya di man unit load. Ang duha ka subscribe dito sa unit load gamiton. So, muna siya ang depiction sa 2. No, depiction sa 2 na siya. So, ako na siya himuon na symbol. Kini siya. Himuon ko na siya subscribe. Okay. There's no problem about that. No? In fact, delta 2 can be determined. But we will just push through with our analysis out. We will solve later delta 2. But I know delta 2 can be solved. Why? Because panahon na to siya sa formula. Naaman niya, sulod niya sa formula. No? Sulod niya sa formula. O equation sub, sa'yo na kayo, no? Double integration technique. You can also use moment area. But I think of the three solutions na atong naibawan, ako lang experience, mas dali it's easier to solve this using equation, no? Because just use the equation, just wag ka sa table sa equation o sa mga load cases with deflection, yan na equation, you can solve with the equation. But we will reserve that later, no? Because our analysis is not yet there. It's not yet, no? So, we still continue. We have not, wala pa ta kabuhat og compatibility equation. Okay? So, bubat pa ta compatibility equation. So, karon ang isa ka case, so this is the one, no? So, remove redundant support. Redundant support. Mauni siya itong ibuhat, remove na to. Manatag remove. Ang sunod is, dinhiyo siya na ko na ibutang para di makasabog sa solusyon. So, procedure, no? Step 1. Okay. Remove by step 1. Is mo na siya kung step 1. Remove by support. Step 2. Din na makuha ninyo step 2. Apply unit load at point where redundant support is removed. Okay, let's remove. Okay, muna siya step 2. So, kumata sa step 1, atong i-remove, nasa delta 2. So, ang sunod sa metabo is, kasi metabo kung ma-apply ka unit load at point where redundant support is removed. So, okay, we'll do that. So, metabo na is mo ni. Wala na kay load. So, ang metabo ni mo diya is, nagyapon ka aning Nagya pong kaning nagya pong ka ay, nagya pong kaning point 1, nagya pong kaning point 2, nagya pong kaning point 3. Okay. But you have really to apply unit load. This one, no? Very important. That's the key. Okay. Now, you might ask the question, where I am going to apply the load? Of course, at the point where you remove the redundant support. And then, tungod kay ang support doon na siya is a concentrated load, so the unit load is also a concentrated load. It's not a, because it is also okay to apply a unit couple or unit moment. But this one, you will just say unit load because it's clear man din nga, ang imong i-remove is a unit, is a load, no? It's a reaction load. Okay, so you can apply it at point 2, either vertical or negative, no? So if you use positive, then you have to apply it up, no? Just like this. Just like this, no? Copy, paste. So kung mo na imong unit load, so pili lang ka na unsay imong gusto. Positive ba or going down. If you apply it at going down, then your depiction could be like this. Ingana imong depiction, no? So ito si ingon na no? Ingana imong depiction. Pero kung imo siyang balihon, dito si ingon na ang wani mo. So ang imo siyang depiction will be like this. Like that. Okay? So whichever you think, no? We'll just say like this. So this one is a unit load. That's a unit load. You say unit load. Okay? And of course, the unit load man siya, doon na siya gitawag na deflection. We just symbol deflection, no? This one. We do not know that amount of deflection, but if you ask me kung ma-compute ba ang deflection using unit load, compute tayo. No? So this one is, ang pagbutang lang sa subscript niya is load applied at point 1 and deflection at point 1. So just say delta 11 small 3D. No? I will use this as my subscript. That one as a subscript and this one as, I use this later, no? Because para ma-distinguish nga unit load ang imong gamit, no? Okay. I will use no unit. Okay. Now, diha ba tataman? Napakuisingit gamay, no? Napakuisingit gamay. Okay? Napakuisingit gamay ani kay. Nagdanag kita diha, no? So, naka-remember mo ani nga kung apply kog P mo deflect siya. Kanya kung akong i-double ang load, mo double sa deflection. Kaya kung akong 10 times ang P, ang deflection niya mo 10 times. So, mapresenta nimo siya kung butangan nimo og P, butangan nimo tawag ani modifier nga n ang P, ma-modify by n sa doang deflection. So, they are linearly related. Ang tawag niya na. There is a linear variation or linear effect, no? Like that. So, just like that, no? Just like that. So, what does it say here in our solution? Okay. That if I am going to multiply this by n, this one also will become n. Okay? So, yeah, no? So, why I am going to use n? I'm just going to, maybe I will use R2. Okay, I will use R2. I will use R2. So in that case, if that is R2, this one is also R2 times. This one is also R2 times. Okay. R2 ba? R2 times. Yeah, kung in times ang load, in times ang deflection, may giingon na ni. Okay. Okay, first I use double 2P, may mo siyang 2 delta. Kung 5P, 5P sa siya. So, P and deflection are related to N. So, multiple by N. But N could be any. It could be, you can use M, you can use Q, you can use any letter. So, here, I am not going to use N, but R2. R2. So, compatibility equation din, compatibility equation is you sum this, no? This is the compatibility equation. Insert, you just sum this. Okay. So you just sum that one compatibility equation that you have R2 times 1. Ito na R2 times 1. R2 dip, R2 deflection 1 1. Okay. And we just use plus, no? Plus we just vary the sign of the load is equals to delta 2 is equal to 0. So, mo na siya. So, kini siya is a subscript. Subscript na siya. Kini siya subscript. Kini siya delta. Mali siya nakuha. Ako na isa ba karon. Okay. The first equation is this one, no? This deflection, this amount, plus this one should be 0. This is deflection 2. This one is R2 delta 1 1. So you just sum these two should be equal to 0. So dapat kung isum nimo ng duha, mo yung ana siya balik siya sa 0, no? Balik siya sa 0. So doon na kay nga nga kuan, gitulod sa 1 pingo sa taas, so musaka siya taman mahimong 0 yang deflection. So that's why the sum of this R211 and delta 2 should be 0. Now you're going to look for that R211. Okay. So here there are the deflections to solve. No, deflections to solve. Deflections to solve. Okay, number 1, delta 2 and delta gamay 1 1. Okay? So, mana siya ang atong isolve. Kini siya subscript. Kini siya liter, Greek letter, symbol. So, I'll just use the different Greek symbol. Big letter delta and small letter delta. And the other one uses the subscript, no? So, using delta 2, ato na lang kong internet, palaban na lang ko, no? Palaban ko actually. Ani ko din sa deflection formula. Deflection formula.
Sir,
Ha?
question.
Yes.
Kuan, deflection 1-1 sir, masing nasa 2 ang unit load.
Ha?
Deflect ay delta 1-1 sir, masing nasa unit load nga 0.2 or
Wala, isa lang. Isa lang yung pangita. Kay isa man actually ang indeterminacy. So you need only one equation. Ang kinahanglan ni
subscript sir ba?
subscript duha. Meaning load gi-apply sa 1, yeah, this is 2 2. This is 2 2. Yeah, I'm sorry. This is 2 2. Oh, that's the question I am waiting actually. Okay. So, okay na.
Salamat sir.
So, load apply that to, then you are going to deflection at point 2. So, determine the deflection at point 2. So, that's the question I am waiting. So, this one is also 2 2. Okay. So, what to ko sa internet, no? Palaban ko kay gusto ko magdali kay may dala ko oras. So, nangutana ko sa internet kung naabay formula sa tawag ay deflection, wag naaman ko no. So, in fact, akong tanaw, no? Okay, I hope this one. Okay, so ako i-share. no? So, ibutang na ko din sa atong lecture. So, naging ko kay ang deflection to solve is still, kung masolve lang yun akong delta 2 to delta 2, solve na ang R2, right? Solve na akong R2 using this equation. Okay? So, delta 2, so, consult ko sa 1. So, mo ni siyang kita na ko sa internet. Okay, so mo ni yung gihatag. Gamay man. Magapayon na nato anyway. Nabito niya sa inyong kwan. So, gamay gid tayo, no? Ana siya. So, kining case 1 o case 3, mo na napag-solve sa delta 2, no? Delta 2. So, using case 1, so we can determine delta 2 here equal to PL port over 48 EI. PL port ba na siya? PL port. Tanaw na to. PL port over EI. PL port ba na siya? PL squared PL squared. PL cube. PL cube na siya, PL cube. Di man maklaro. Atong dakuon ko, no? So, dakuon na to. PL cube bagyod, tanaw na to. PL cube bagyod. Lagi PL cube, dakuon sa gayo. Okay? So, doon na kay, we are calling the deflection here as delta max is the same as delta 2. So, I will write delta 2 here. Okay. Delta 2 is equal to, ang P niya is positive, no? Positive going up. So, this will be positive. P is 1. Actually, the formula is like this. So, PL cube over 48 PI. Okay? So, pwede mo ang capital L. PL cube. Okay? So, may tabo na niya, isingin na niya. Remember, ang unit load mo, wala unit ha, wala nang butag unit. So, this one will become 8 cube. 8 cube is 8 times 8 is equals to 512, no? It should become positive 1 times 512 over 48 Pi. So, may mo na siyang 512 divided by 48. You have positive so 32 divided by 3 Pi. So, mo na siya. Ang unit, ang L cube carries the unit, so you have meter cube divided by EI carries Newton meter squared, no? Because I is meter to the port, this one is Newton meter squared per meter squared, so Newton meter, that is the unit, no? That is the unit. Okay? Or meter cube divided by meter squared, this will just be meter Newton ang remaining unit, no? Ang Newton wala na cancel kay may unit atong P. Kung napunta kay P, meter ang kuan. Wa man to butang og unit ang unit load. 1 naman yun. So, ang easy cut case, we have case 3. Okay, case 3. So, we have delta 2 is equals to, ang maximum deflection niya is 5W. 5W L fourth over 354 EI. So, muna, ang dito, correspond to the maximum, no? So, ini siya will become a subscript. This one will become, I hope I can do it. Okay. So this will become, I put it here, time is running out. Okay. So you have L to the port, L to the port, yeah, L to the port. The L is 8, okay? 8 to the port, 4096 times 5 times W, which is, W here is negative 20 because that's going down. So times 20. So we have 5 times 20 times 8 times 8 times 8 times 8 divided by 384. So we have negative 3200 divided by 3 divided by 3 EI. Okay, the unit. Okay? Kini siya is Newton per meter multiplied by meter to the fourth. So, nado na kay Newton meter to the cube. No? Ang ang sa ilalom, doon na kay Newton meter squared. Okay? So, muna siya sa denominator, ay ang unit. Yan, muna siya unit sa denominator. So, Newton will cancel. So, ang remaining unit niya is meter. Yes, meter. Meter na yun. Okay? So, equating the two, we have R2, we have this one here. So, and then substituting that. So, we have copy, paste. So, delta 22, which is 32 over 3 EI. This one is times 32. 32 divided by 3 EI. And kay minus 3,200 divided by 3 EI equals to 0. So we have R2. We have R2 equal to, okay, R2 equal to, okay. So if we transpose this to the other side, it will become 3,200. So the R2 is 100 EM. 3,200 divided by, okay, 3,200 divided by 32. So 100. So 100 siya, 100. So R1 and R3, R1 plus R3 is equals to, okay, plus R2 is equal to 200 times 8. What is 200 times 8? 1,600. 200 times 8. 200 times 8. 1,600. Huh? Yan. Okay. Something is wrong. 200.
Tsaka sige ka ng 200, sir.
Huh?
Naging ka ng 200, sir.
20 na 20.
Ay, sir.
20 ba? Times 8. 20 times 8. 20 times 8. 160. I have something this now. So you have 8 times 8 times 8 divided by 48. You have 10 times 3. That's 32 over 3 EI. 32 over EI. About this one, 8 times 8 times 8 times 8 times 20. Okay, divided by 384. 8 to the fourth times 20 times 5 divided by 384 times 3. 3,200 million. 2,200 EI, 384 EI, 48 EI. This is the deflections. So it happens that 100 PN. So PN, you have R1 is equal to R3. Effective ano ba sila? 50 PN. 50 PN. But this is too big, no? Too big. I must have been something wrong is here. PL cube, that's 1 over 40 API, that's correct. PL cube over 40 API. Maximum depiction 5 W input 384 384 384 348 384 EI. That's exactly 8 equal to the 4 times 5 times 20 divided by 384 times 2. Sakto lang 3,200. So if you add them at 100 km, so might see that you'll have a moment diagram like this, moment diagram like this. Okay, and then the other one. Okay, so this one will be 30 here, 30. This one is 50, 50. And at the bottom, this is 50, 50, 50. This one is 30, 30, 30. So that is my shear diagram. Okay. Shear diagram. B diagram. Now, the moment diagram might be like this. In diagram. One line, I put a line here. So this is the shape. Okay, copy, paste. How to click this? To click this, I'm gonna click that. Then I have to do it another way. Insert sheet. Okay, so your moment diagram will come like that. Okay. Your maximum moment always before zero shear. So zero shear is here, so it must be here. Maximum moment. Okay, you can determine that. Okay, so this is your moment diagram. So this is now the analysis after. Yeah, so the time. So I'm not quite sure. I'm not. Well, no, I will just check. I'm doubtful of the figure. So this is how you solve it, no? So this is just an example class, no? How we do it using consistent deformation. So it's not really as straightforward, no? So you have to do a lot of determining deflection and some tawag aning mga geometry, no? You are going to understand the geometry of deformation. Okay, class, we do not have time anymore, no, but we managed to finish the problem. All we have to do is we have to repeat this next meeting. But next meeting, we have a quiz. Huh? So, bali, discuss na to ni siya sa Wednesday na lang ni Wednesday. Wednesday, we don't, no, what mo tayo Wednesday ay? Yeah. Sa Thursday, we'll have an exam, so we might discuss this in the laboratory. I will do the exam in the afternoon. Okay. So, that's all class, no? So, this is really a very long solution, no? But this is how it is, no? We solve deflection twice, then we do the addition, then we solve. Okay. So, if you want, I'll post it in the e-learn so that you can use this as reference, no?
Asa
Okay.
gani so good ang
Ang exam na to will be about deflection lang, no? Using equation, using moment area method, maybe double integration, I will ask that, no? Because the exam will be multiple choice, so the answer is already there. So sometimes answer comes very obvious, no? That this one is the answer, no? So, but it's good that you will have to solve really, no? So it will be all about deflection, the exam. Okay, class. So I will stop.
Salamat,
Yes,
sir.
sir. Excuse
I
me,
will just post
Thank you,
this
sir.
Sir,
Na
one
kay
minute.
concern, sir.
kung sa man imong concern.
Katong all assignments bitaw, sir, kay napas na ko sa Gmail yung sir ba kay nag-reason na mo ko sa Gmail, sir. So wala na ako napasa sa e-learn, sir ba. Appeal
Sa
po si
Gmail?
Lex daw, sir.
Kasi ngalan nimo Luzano, no. Okay, ako lang
Okay.
magitaon dito ha.
Ug si Lex daw po, sir, kay wala sila kurente karon, sir.
Kinsa may wala na ka sa submit line.
Ako, sir, sa una.
Santos, magyapon.
Sa una,
Wala
dili,
yapon
sa
nimo
una.
na.
Sa una to, sir, sa una.
Na-submit na nimo sa e-learn or sa
Gmail, sir.
Oh, Gmail. Isa pa yung nag-submit sa Gmail.
Ako, sir,
Si
sa
Lex, sir.
Oh, okay. So, anyway, kung pakitaan ta mo, yung hindi lagi na ninyo yung mga assignment, ayon yung bulaan ng mga soft copy kay it's possible nga dili na ko siya makuan. I will ask that kay kaya kompleto gid ang inyong kuan ang record sa inyong mga assignment. Ito assignment nga akong ipanghatag pangitaon ko siya, no. So, pag abot sa kunin tayo sa grado, no. Okay? Oh, yes, Mr. Nali, so may problema. Unsa na siya imong problema assignment? Lagi. Ah,
Yes.
can you submit that in my Gmail? Iusan na lang, isunod-sunod lang ba? Pagbutangan na nimo siya o note nga, this is for homework number 1, homework number 2, something like that. Then, so
Sir, when
ini,
itong exam, sir?
Juan, our next meeting will be Thursday, right?
Yes,
Okay,
sir.
Thursday. Di ta mag-exam sa Wednesday kay mag-exam ta sa hapon sa Thursday.
Unsa oras, sir? 12:00?
No, gihapon.
Okay.
I will not be around then because it will open. The exam in e-learn will just open and close.
Okay, sir. Thank you, sir.
Okay? So, katong wala na ka-submit kay na ay mga rason although na nikahamot din mo nga mag-submit, just email it to my Gmail, but you have to inform me, ha? Kay usually I will not look for assignments in my email. Kay grabe yun ka puno ang akong email lisod kay mangita dito, no? Lisod kay mahukay. Okay. So, okay, so I will exit, ah. I will exit.
Salamat, sir.
Bye, sir. Thank you, sir.
Okay.